I was asked to make a video about the roller here, some of our likes and dislikes. As I mentioned in previous videos, we built this roller. This is, and for those of you that have watched my channel, have seen, I have a video of another roller. We built two of them. This is the first one. This one's a two roller. It's made out of two 36-inch diameter oil field pipes. They're 5/8 inch thick. Each roller on this roller weighs about 4,000 pounds, and that was before we added all the axles and the bracing inside and the end caps. This one we built in the spring of 2011, and we got 3-inch diameter bearings on it. So I was asked some of our likes and dislikes of this roller. Well, first off, we like it. It's heavy, and it does the job for us. We have a lot of rocks here. I've mentioned it several times, and this punches them back in the ground. I mean, they got to be a basketball-sized rock before this won't put them back in the ground. But on the same, and the other thing that's nice about this style of roller. It applies equal pressure all the way along its 33 feet of load-bearing surface when it's in the field. Other styles, and like the other one we built, it has different pressures on the ground at different points along the roller. But based on this design, with the pins in the center of each roller and the whole frame sitting down on those rollers, it applies equal pressure all the way along. So, I mean, what else is there to say on a field roller? It does its job. It pulls fairly well for being 17,000 pounds. Like I said, we pull it with this 766 here, and it has to get into some adverse conditions you really probably shouldn't be in to begin with before this tractor has an issue. It did get somewhat of an upgrade this year. We converted from 20.834 bias ply to these 18.438 radials, which actually quite surprised me. It pulls just as good with these radials as it did with the bias ply. And when we get some newer, better radials, it'll do even better. But anyway, we do have a few things on it that we made, I would say, mistakes in construction. Didn't quite realize some of the stresses that we're going to put on things. For like example, these frame rollers here, these frames around the roller, when we picked it up and put it into transport position, there was a significant bow to the frames. So when we built the next roller, that had some smaller rollers on it. So each combined, the rollers weighed the same, but each individual roller was lighter. So we took the frames out of this one, hacked them apart with the plasma, and we built new ones. These ones are 6x4 by 3/8 inch wall tubing, square tubing. The other ones were 1/4 inch wall. Believe it or not, you can still see a deflection if you look down the length of the frames, but it's significantly less. That was a fairly minor mistake. It didn't cause us any issues, but the tongue, that was where we made a bigger mistake. This is still the original tongue, but we broke it. Up here, where the rams connect, I don't know if you can make it in or out, see our welding up there, but we broke it there, and that joint at the top, and then there's another joint at the bottom, just the same. We broke it in those three locations. I guess I shouldn't say broke it, because it didn't actually come apart, but there was cracks forming. So up there we gusseted it and reinforced the joint, and down at the bottom. And in those two locations that worked. We broke it a couple times there, and it's just not heavy enough. We made that a 6x4 1/4 inch wall material. It needed to be heavier. 8x4 1/4 inch wall would have been a significant improvement. But we're going to make it out of 8x4 by 3/8 inch wall. Now, that's going to add some weight to it. I can't remember. I figured it out one time, but it's going to add some weight to it. And that leads us to our other issue with the design of the roller. I shouldn't say the design, the way I designed it. I made a calculational error when I designed it, and we're going to rectify it this coming either this year or next spring. I figured out the way to fix the design problem. But anyway, yeah. So a new tongue is also in the works. There's nothing on this one that we can reuse, unfortunately. So this is just going to be, well, not scrap iron. We'll cut it up, and all those, every tube is good for something. So. The other problem that when I designed it, I made a mistake, was these rams. Now they look impressive. They're 4x8 rams with a 2 1/4 inch rod. And by my calculations, this should have made this thing fly off the ground. But I made a mistake. I forgot the lever. So the ram is only about 1/3 of the way down the lever. So I lost 2/3 of my lifting power. And so it does lift it. It's a struggle for some tractors. The 766, it can lift it, but it's a struggle for this one. It only has a 21 or 2300 psi hydraulic system on it. If you hook it to a tractor with 2500 psi, it lifts it okay, but it's on the verge. So what we're going to do is we're going to put on different hydraulic rams, redo all the mounts. So I've purchased 5x12 rams. So essentially what we're going to do is the holdup you see behind will go here in the front, and then the new ram will pretty much go where the holdup goes. Of course the mounts won't work, but that's the plan on that. So then we won't have an issue. And again, when we add that new tongue, I think it'd overpower even these rams on a higher PSI system. So other than that, that's the 2 or 3 design issues when I designed it. The only other real thing that the other roller, well, comparing this roller to the new roller, the one that my cousin has, is just speed in getting it to the field. His roller, you set the main rear roller down on the ground, you fold the wings out, put the main system in float, hydraulic system in float, and off you go. I mean, it's like a 30-second operation. This one, it's a little more involved. There's lots of hold-ups and stuff like that. So you have a hold-up here that holds the rollers from pivoting when you're going down the road, and there's one on each roller. And then these hold-ups that hold the wheels down, so you're not resting on the hydraulic system all the time. And then there's also a hold for the tongue that you have to pull the pin. So I'm going to demonstrate setting it in and out, full blown, and you can see this one. Now the other roller, the one in the previous video was about here a couple years ago, that one, it's all by gravity. When we designed it, took this lesson into account, and we made it so that everything is by gravity. So it holds it up by gravity. There's no need for any lock pins or anything like that. So I think I covered all of our likes, dislikes on it. Here, I'm just going to do a quick demonstration on setting it in and out. Here we go. So here it is, set out. This is the field position. As you can see, I had to put the lock pin back in its saddle. But yeah, so here we go. We're ready to go. Keep in mind though that we're doing this on a gravel driveway, and there's not much resistance to the rollers moving because they have to roll as you roll, spin it out. In the fields, it takes a lot more power to twist it. A lot of the times you have to give it a little helping hand with the tractor, actually by rolling the tractor forward and back. And it just kind of makes it just helps a lot. But yeah, so here we're gonna set it back in and put it away. We're done for the season. I just thought I'd make this video. Here we go.